How to measure performance. In the context of this course, performance measurement is used to assess the gain from parallel execution. So the performance measurement we use is time, and the time to complete the application execution. This is also called the latency of the computation. Here is an example of how you can measure the performance of a piece of code by using the getTimeOfDay routine and convert the time returned in the data structure here into seconds. So here, by adding seconds and microseconds here, you can measure the time, for instance, of this piece of code. Here is the result you get. So if I launch wallClockTime.exe, after I have compiled the code, I will get starting to display here, and I will get the second answer here. And that's about 2 seconds. What you see here is a result of the Unix time command, and it gives you the real time, which should be equal to this one, and the user time, that is the time spent for your process, okay, and the system time, so that's all the IOs, page fault, etc. So when you use time and getTimeOfDay, and if you're measuring almost all the code, the real time and getTimeOfDay time should be equal. Another measurement that is frequently used is flops. It measures the number of floating point operations per second. And this is useful when you know the number of floating point operation you will do for your application. So, for instance, if you're doing a matrix multiplication of square matrices of size n, the number of operation you will do is 2n at the power 3. And usually we use flops as megaflops, 10 at the power 6, gigaflops, 10 at the power 9, teraflops, 12, and petaflops at the power 20. Current supercomputers are here. And exaflops, this is the current challenge. Usually when you do the computations, you indicate if it's in single precision, that would be 32 bits computation, or double precision, that will be 64 bits. One of the advantages of this measure, so if you compare your performance in flops, megaflops, gigaflops, then you can compare it to the peak performance of the machine. So you know how fast you are regarding to the maximum power the machine can deliver. So in that case, the flop measurement is a nice one. However, in many cases, you don't have flops. You can't use that to measure performance. For instance, an integer video decoding where you will count as frame per second instead of flops. But the main measurement is time, and a good measurement is equivalent to time multiplied by some constant or something. CPU time, for instance, is not a good performance measurement because it doesn't include a lot of things that happens during execution of the program. For instance, the system call. That is not taken into account the CPU time. The system time, because it's the system time, not the application time, etc. So only the wall clock time is a clear measure of the performance. When you measure performance, it's not as trivial as it looks. And one of the key questions is what is being measured? Right? And to answer this question is non-trivial. For instance, many parameters influence the execution time. So how did you compile the code? Which compiler you use, the system load, the IOs, the input data sets that were used to run the code, the application, the stability and the setup. So let's give you an example of checklist, the things you have to check before you can make a measurement properly. For instance, you have to make sure that the code you're dealing is giving the right result. Okay, so first you have to check the result, make sure they are correct. And that question is usually more complicated than it seems, because you are in the process of optimizing a code or parallelizing a code. You do many different things, and at some point you may just forget to check, and so the performance might have improved, but the result might be incorrect. And I've seen that happen a lot. Are you sure you're compiling your application with the right compiler flags? We will see that later during this course, but this has a strong influence on execution time. Have you removed the debug flag? It's also influence. Have you removed the profiling flag? Are your data set representative of the real problem? Is the timing measurement consistent with the goal clock and the Unix time? Usually behind this question is, did you do the measurement using two techniques and check that the two techniques are giving consistent measure? It's so frequent to make error in the measurement, then it's extremely important to have two ways to check that what you are doing is proper. Another thing is, does the Unix time comment so it's indicators an important system time. So that is, if your system time is important, that means you're spending time in IOs or in page faults. So there is probably an issue with the application. Is it stable between runs? So usually an execution should not be variating more than 5%. Otherwise, that means there is something on the machine that is perturbating the execution. Are you alone on the system if you do the measurement? Because one of the things, the wall clock time, the execution time of the application is the right measure, but it assumes somewhere that you have 100% of the machine for yourself. So if somebody else is using the machine, it will perturbate your measure. So you want to make sure this is not happening. Did you compute many runs so you're sure that your measurement are properly done? You need more than one execution to understand that. Is execution line long enough compared to the timer accuracy? So usually you don't want to measure things that are too short in time because the timer will give you a picture that is not the right one. And there is many system-specific questions. So for instance, if you are on GPUs or other accelerators, you might have questions specific to this accelerator. Question for the lesson. What is get time of day accuracy? Most of the CPU have a cycle counter. Why is using this counter measure to measure execution time a bad idea? For instance, remember DVFS. Okay. What is the impact of DVFS on cycle counters? Why system time should be small? Okay, I said before that you have to have a system time that is less than 1% or around 1% when you measure things. Why do you want that? One reference about correctness of performance measurements from C20 from Versailles. And see you in class.